Welcome, everyone. Today, I'm excited to introduce you to McGinty AI's educational platform that explores the theoretical frontiers of physics. We've created an interactive tool to make complex concepts in warp drive theory and gravitational fractal engineering accessible to students, researchers, and physics enthusiasts anywhere. As you can see, the interface features the McGinty AI brand in the header with our distinctive rocket icon symbolizing the drive towards innovation in theoretical physics. The clean layout is designed to guide users through the complex mathematical concepts in a structured way. You'll find the learning modules in the navigation panel. These 8 sections provide a comprehensive journey through the McGinty equation framework, starting with the fundamental concepts and then progressing to practical applications and challenges. Let me walk you through some of the key sections. The introduction section provides an overview of the McGinty equation, or the MEQ. So this is the foundational equation that combines quantum field theory, fractal geometry, and gravitational physics. This is a very elegant formulation that's the cornerstone of our theoretical framework for superluminal transport. The fractal metric section, here we can kind of see how the framework modifies the traditional Alcubierre metric with fractal correction terms. The interactive graph demonstrates the relationship between the fractal dimension and both the velocity potential and the energy requirements. You can see that as the fractal dimension decreases, the theoretical maximum velocity increases, but so does the energy requirement. This fundamental trade-off is the key to understanding warp physics in our framework. The energy tensor section reveals how fractal corrections to the stress energy tensor can provide the necessary negative energy density to support the warp bubble formation. The key insight is located in this blue box, which explains how our fractal approach allows for localized negative energy density without violating global energy conditions, which is a critical breakthrough for making warp physics theoretically viable. The Einstein equations section shows how the McGinty stress tensor serves as a source for spacetime curvature. Users can experiment with the simulation parameters at the bottom, adjusting the fractal dimension and the desired warp velocity to get an intuitive feel for how these parameters interact. So while this is a simplified interface, it helps visualize the complex relationships at work. The quantum stability section, this addresses one of the most challenging aspects of the warp theory, which is maintaining the coherence at the bubble boundary. Our framework introduces a stability equation that ensures that the quantum vacuum regularization, which is preventing the Hawking-like radiation that would otherwise destabilize the warp field. This is essential for any warp theory to maintain structural integrity. And then the warp Lagrangian section provides a complete mathematical description of the warp field dynamics. This detailed table breaks down each component of the Lagrangian, explaining its physical meaning and the role in warp physics. This is a very comprehensive approach and allows researchers to understand exactly how field propagation, stabilization, and spacetime coupling work in our model. The velocity scaling section here. This explores the relationship between fractal dimension and maximum achievable velocity, so that the graph clearly shows how decreasing the fractal dimension theoretically allows for higher maximum velocities. But the current calculation suggests that a fractal dimension between 2.1 and 2.3 represents the optimal balance. This averages out speed potential, and energy requirements. Finally, for our practical applications, this section shows the possibilities and the significant challenges of this technology. So we provide a clear research roadmap that outlines the path for right here, from the theoretical conception to experimental validation. We have a realistic timeline with honest expectations. This assessment helps keep set appropriate expectations while it also maintains enthusiasm for the potential breakthrough in this field. The interactive learning feature down here This is where users can explore key concepts about the McGinty equation. So you can click on any concept card to expand it and learn more. For example, the fractal geometry and space-time concept explains how multi-scale structure creates more efficient paths for energy distribution and field stability. So McGinty AI really transforms complex theoretical physics into an engaging educational experience. So while warp drive technology remains firmly in the realm of speculation, this platform provides a rigorous mathematical foundation for understanding how this technology might actually work someday. It's a very valuable tool for physics students learning about advanced field theories, for researchers that are exploring new theoretical frameworks, and anyone fascinated by just the frontiers of human knowledge right now. Thanks for joining me in the demonstration. I'd be happy to answer any questions that anyone has.